So that leads us to the next point on the agenda, which is James Burk moderating this panel debate about what do we do next, essentially, and what did we have for title for it? I forgot. The title is the role of a moon colony in an interplanetary society. So pretty long term. When we have succeeded in both the moon and Mars, what is the role of the moon in that context?
Yeah, I mean that's a very interesting topic. When we talk about having a permanent settlement on the moon and a permanent settlement on Mars, and both of those realities being present, what is the role of the moon? Yeah, I mean the moon's going to be a critical place where hopefully we have a large lunar ice extraction industry where we're creating fuel and raw materials and resources on the moon that then could be used in the rest of the solar system. It's much cheaper to launch water from the moon than from Earth. It's much cheaper to develop rockets and other vehicles and other technologies on the moon and launch them from the moon than to develop them on Earth and launch them from the Earth. And so I think the moon is hopefully going to have a permanent settlement before Mars, and hopefully it'll outpace Mars, because Mars is a lot harder to get to and a lot more expensive as a result. You have to a much bigger sort of order of magnitude mission to send a crew to Mars. It's a 3-year mission. If you send a crew round trip with conventional propulsion, 3 years. That's why we haven't done it yet. Whereas the moon there and back would be like a week. So, you're going to need to have a lot of infrastructure on the moon to support the rest of activities in the solar system, whether it's Mars, Europa, Enceladus, the belt, orbiting space colonies around Earth. A lot of those are going to get supplied from the moon because it's going to be cheaper to send stuff from the moon.
Yeah, that's funny. I disagree with two things you said. One is that we should ship water from the moon. It isn't that much water on the moon. We should use it for habitation and settlement rather than fuel. You can use aluminium. You can make rockets out of solid aluminium and liquid oxygen. But plenty of that on the moon. Ship that instead, please.
Well, what I actually said was I hope there's a lunar fuel station on the moon. Maybe that's being supplied by belt asteroids. Because it's cheaper to go there and back from the moon than from Earth.
Yep, that is true. I agree on that. The other thing was that you think that long-term moon will outpace Mars. Why would the Martians go back to Earth That's part of the solar system, and Mars is bigger than the moon. I would assume that long term there will be more people on Mars than on the moon.
You're probably right. When you think far future, I think you're right. Mars has the same land area as the Earth. Mars has a lot more resources than the moon. Mars has natural gravity. It's a little bit stronger than the moon. Mars has an atmosphere, mostly carbon dioxide, 1/1000th the thickness of the Earth, unlike the moon. So there are advantages to being on Mars. I'm not, but I'm not here to sell Mars to the moon crowd, right? I'm here to say that, in the near term, I think we're going to see, because the moon is quicker to get to, because it's cheaper to get to, because it's only, 1 second delay communication, only 3 days by chemical propulsion, maybe less with nuclear. It's going to be a lot easier to build infrastructure and send people to the moon than Mars. Mars is going to take some careful planning. There will be starships, heading to Mars with 100 people inside, and maybe a bunch of them at the same time. So you will see that, but we're still 5 to 10 years out from something like that. Even starting.
Or a few years before that happened. Yeah. Do we have anybody else in the panel that want to say something? Maybe it shouldn't be just you and me talking. Or Uh, Anybody else in the panel who were asked to
I'm happy
want to?
to. I'm a
Yeah,
willing victim, Nicholas.
yeah. Sorry, you are?
Madhu.
Yeah, yep, I see that. Yes, proceed.
My advice to those who are pondering living on Mars is I wish Mars were closer to us, that we could really think about doing something in the time frame that we could do things on the moon. In fact, there's even a group that think we should live in the upper atmosphere of Venus because Venus is closer, and proximity is the killer. At least using the technologies we muster today. Every time you go to oh, I should start my video. Okay. Every time you sit in a hardcore engineering group, we hear a lot of chuckle about folks wanting to go to Mars because we always get arrows on, hey, how do you do this? How do you keep people flying for months on end on an interplanetary trajectory? They're all getting fried and their brains are getting cooked. They would even be able to switch on different critical systems when the time comes for descent and landing. And these are all hard problems. Um, so we have to curtail ourselves to short missions in the near term, I think. But we should keep that vision open for
Sorry, I have a
longer
question to James,
missions.
since I have this opportunity. You recently had analog mission. What is your experience? What did you really learn? And also for the lunar mission and Mars settlement and lunar settlement, what are the difference between analog station and actual real station? How do you see that building the settlements on the moon or Mars? Thank you.
Well, let me tell you, Marufa. You can
Question to
open the
James, by
door.
the way. Sorry.
No, let him. I'll answer, but let Madhu say something.
You can open the door and walk out of an analog station. You cannot do that on a real mission.
Yeah, that is the biggest difference. Is we always can break sim if
Right,
there's a
right.
real safety issue, and safety is always number one for what we do. And unfortunately, no one's ever died on an analog. We want to keep that streak going for sure. But yeah, to answer your question, Marufa, so what did I learn on my mission, which was Cruise 261, and then I just did one with a few people, Crew 300. That was more of just a quick one to show some partners what the station was like. What I learned during my full 2-week mission with 7 professionals was that we could do living in space. Like we've learned enough today about how to work well together in an isolated environment like that. We have learned enough to keep everyone safe and to work well together that by the end of that 2 weeks, I felt like we could have kept going for a year, no problem. And for me, it was about having a team that worked well together. And that took time to plan. Like our core group of 7 people, we actually were planning for that mission for 4 years because COVID kind of delayed us. But that also gave us the opportunity to really load up the science and learn how to work well together with each other. A couple of my crew met in person. The folks that lived in Europe met. They all went to IAC together one year. But we also had weekly Zoom calls for like 2 years. where we were trying to plan everything.
Yeah.
And so when you have a group of people that work well together and they have bought into the mission of exploring the moon or Mars, then they can do it. They can take care of each other. We're ready to do that. It's not an insurmountable thing. Even the radiation concern that Madhu mentioned is solvable. You could solve that with adequate radiation shielding and procedures for a solar flare to have a shelter in the spacecraft transiting or on the moon or Mars. So that, that's what I learned is we're ready and we're learning more every time we have a mission. And then you also asked, Marufa, I think you also asked the differences between a lunar, analogs and a real mission. Yeah, the biggest one is it's still a simulation, so we could break sim. I mean, the other thing is we're not really working with real hardware. We're working with analog hardware. So it's not a full fidelity simulation. It's more of an operational simulation. Getting your mindset into it and what it's going to be like to have people work together in an environment like that. So we still when we have a crew that's about to go to Mars, I would recommend you send them to the moon first or Antarctica or something. So they can practice working together in a real space environment before they go to Mars for 3 years, So it's still we still have more to learn, but I think we've made so much progress in the last 20 years in this field.
Yeah, thank you for inspiring and making us crew member and analog astronaut. Thank you for supporting.
Of course. Any other questions or comments on how does the moon, the panel topic, I think, is how does the moon, a permanent base on the moon, affect the rest of the solar system? What's its role in the human spacefaring future? Any thoughts on that?
I would say that it's possible to still be sort of gas stations for transport all over the solar system, not using water, but there's an abundance of oxygen on the moon. And if you have, let's say, using oxygen as a propellant for nuclear thermal rockets, that could be a solution for, let's say, very long trips to Mars or elsewhere. And if we can solve the radiation problem and maybe also the problem with low gravity with having, let's say, some sort of rotated structure, whatever, we can have more of a historical analog to the age of sailing. I had an Earth globe from 1910, and the European port of Bremerhaven to Valparaiso had the route in small dots on that globe, and that took 90 days, 3 months. I mean, now you're approaching times to Mars, even if Mars is still longer. But if you have a big enough ship, it could be more like, well, to be a big accelerated sort of a cruise ship that you can easily live on for a number of months without actually dying.
Interesting, Wolf, that you say that if you have very large space ships, let's call them ships because it's going to carry a lot of people, and that is what Elon hopes to make a Starship evolve into. You can imagine that these are floating cities, carrying all that you need for as long as it takes. I've had students in the class talk about interstellar generational starships and so on, but it's in a different class all by itself. Most of us are grappling short-term problems,
Yeah,
There's a bit of an opportunity there, in between. One of the things that we did as part of the National Space Society Space Settlement Summit is we asked Royal Caribbean to come in and talk to us about through an ideation exercise as to what a cis-lunar cruise ship
Would look like,
would
yeah.
be. Okay, so that's an example for of where you've got anywhere from 250 to over 6,000 people, plus crew,
Yeah.
that has established business models, and there's some interesting angles to explore there.
Yeah.
But there certainly are things, and we need to be able to have our vision of what is possible. Be something that we can grow into. There once was a time when NASA's notion of a forward-looking space program was advocating better weather satellites. Okay, we've
Evolution.
got to have a wide enough worldview to encompass the future we wish to see come to pass.
I think Gary is a hard-headed engineer, and I know that because every time we get into discussions, he will start crunching numbers and then put it on a timeline and see how this might work using real technologies. It frustrates everybody, but somebody has to say it.
Hey, there's a clear and present danger if you if you ask an engineer a question, they're going to want to answer it, and if you look puzzled, they'll try and answer it again from a different perspective.
Hey, James, this is Philip from President of the Moon Society. Number one, I
hello,
want to
Philip.
thank you for your comments earlier about getting LDC started. I do have an idea that I've been floating around, and I would love to have your input. And I think this is something that would help us, all of us, take it to a next level. I think I would love to see an actual high fidelity analog. And by that, I mean by like taking over a complete mountain valley, capping it and turning it into a vacuum chamber in there, covering the whole surface with, actual geological materials similar to both Mars and on the moon. And I know that, we all know that we have Elon Musk backing for, becoming a multiplanetary species. But I think that before we can really do that, before we spend, hundreds of billions of dollars to send people to Mars, or, almost that amount to even start laying the groundwork to do stuff on the moon, we really need to test, to basically engineer. Well, let me back up here. When we do engineering for a product, you go through an iterative process to tweak what's wrong, what works and what doesn't work, and eventually you figure out a system that allows you to really just test the entire process. We don't have anything like that for doing any long-term operations on the moon or on Mars. And one of the speakers from yesterday had in her Facebook profile, actually I think it was Madison Feehan. She quoted a comment from former NASA director Dan Golden, who said that he doesn't care about your design, he cares about your operation. And I think that kind of is what we really need as an entire, as a species. This is what we need in terms of like really moving the dial forward in terms of truly operating in space. We need operations that allow us to know what the transition point will be like to go from us sending products from Earth to going ISRU locally on both the moon and Mars. And I was just wondering, maybe there's a way that we can try to facilitate a conversation with both NASA and, the major funding backers for space to try to build that high fidelity analog. I'd just like to have your thoughts on that.
Can I have a thought with this kind of relevant? It's a slightly different way of getting the fidelity. I would like to have a volunteer town, mid-sized town that studies that volunteers to be cut off from the rest of the world with a bit of time lapse in communications and try to get completely self-sufficient. I think that is something that would be needed in order for a large-scale town or city on either the moon or Mars to be tried out.
Absolutely.
Same thing actually with the generation ships. In order, before we send a generation ship anywhere, tell your student that, Madhu, then we need to try it out for a couple of generations in orbit around the sun first, of course.
Sure.
Yeah, the closest we've ever come to actually attempting a high fidelity analog was Biosphere 2. And that was maybe 30 or 40 years ago.
So I wanted to mention that in response to your question, Philip. There is an analog called SAM, Space Analog for Moon and Mars, at Biosphere 2, that's being developed by Kai Statz and his team at the University of Arizona. And it's going to be, as I mentioned, a Moon and Mars analog. There is a Mars yard that they've built. It's inside a large, like, warehouse-sized building. You kind of walk out of the airlock of SAM into this Mars yard, and it looks like a movie set. It's got foam painted rocks on the walls, and it's going to have an impact crater. And so they're designing it for use for both a lunar and Mars analog, and they're going to build a specific lunar terrain outside of that building as an extension next. But take a look at what the SAM folks are doing at Biosphere 2. You're right. Biosphere 2 was the first and still best version of an actual Earth biosphere in a building, in a terrarium. Like that's what you're talking about. Is like you had the idea of capping off a valley. I mean, what they're doing is kind of a building, a hermetically sealed building with some shipping containers added on, and then this Mars yard building as the EVA area. But the rest of it is pressure sealed, and they have a pressurized suit. Like they're really doing a higher fidelity analog than we are.
Yeah, am I right to think that NASA is starting to do that with their Mars simulators and?
Yeah, the NASA Johnson has has the Mars facility.
That's Hera.
It's more structure than anything else, but my understanding is their intention is to layer on additional levels of fidelity.
Yeah.
Yes.
I agree with Nicholas that when you go to an architectural part of thinking, you must first look at small townships and how they operate. So in the next meeting, we would like to have some city managers talk to us. I know one or two out there in the desert, by Palm Springs. The problems they have and the opportunities too are quite interesting, because when you remove yourself from our comfortable surroundings and go out into a remote part, just go down to Hesperia in the high desert, you see problems as they appear, and so there are many towns like that operating now on planet Earth. It'll be wonderful for the Moon Society to produce a book on these remote facilities and how they operate, because you'll get to see real data. What does it take to bring the logistics up to a level, up to a standard, to keep 300 people running? There's a place in Australia called Coober Pedy, which is also underground, keeps a few thousand people running. There are places in Turkey where people live underground. India, old civilizations have a lot of people in these small little clusters or townships. It'd be wonderful to see a book out of Moon Society showing these real numbers.
You can also see cities in the far north, both in Canada and in Russia. And there are lots of small cities on the townships or in the very north of Siberia, which is
That's right.
close to the outer world, 6 months at a time. The only way to get something in is to fly
Right.
in, and that doesn't happen too often. And Canada has,
Alaska too, Bob.
yeah,
And what I know from data that I gather from psychologists are there's a lot of problems associated with the human psyche in many of these places where people have a lot of abnormal difficulties.
yeah, that's the same thing. In the far north of Sweden, lots of people suffer from SAD, which is sort of seasonal depression. I don't think you have hit that problem.
We have that in
because-
Seattle too, Ulf.
You do, yeah.
Right.
I recall that at least in one Mir mission, there was violence slowly building up over a period of time between the crew. And I'm glad that one of you mentioned, Jim mentioned Biosphere 2. I was in constant contact with the first two experiments when Tabor and Jane and Dr. Walford were in there. And I recall that the atmospheric constituents started to change.
Yeah, they were conflicts. But on the other hand, 6 of the 8 members married each other afterwards. So it could be total conflict.
I mean, good things can happen too. But anyhow, these are experiences. And I think NASA too, in the current group of candidates for astronauts, they have teaming as part of their exercises where you fly them to different places and make them come together and as a team, because in the old adage, no man, no human is an island. It becomes very important in
Sorry, I have to interrupt again because I only know James in person. I want to ask one more question. So you were showing a chip where kind of looks like a radio, but I was thinking for the spacesuit design, what we have in MDRS, we wear that big backpack. Like what do you guys have inside? And second question would be, can I have, let's say, 20 quantity of 20 in my Everest Innovation Lab in Hawaii, so that you can showcase some spacesuits? So expensive.
Where
in
Hawaii are you?
I'm in Honolulu based, but right now I'm traveling in Minnesota.
Well, you want to talk to Hank Rogers and see if you can.
Yeah, I
get
know
into his
him.
group.
I know him.
He was here. He was visiting here just a few weeks ago, and you may want to talk with him.
So, James,
to answer your question, Marufa, we have our chapter in Northern California in San Francisco. They work on our suits for MDRS, and they improve them every year. I took the suits from the station there a couple weeks ago for them to start working on them, and talked to the head of the chapter, Scott Davis, and they have plans for a new suit that they're designing right now. But the ones we currently have, there's 2 different models. There's a 1-piece and a 2-piece with a helmet and a backpack. And then there's the first one is just the integrated full thing, has the helmet and the backpack. It's essentially, it's a helmet with a airflow into it from the backpack using just regular off-the-shelf fans that you might have in a computer, for example. And there's a battery pack. The radios are separate. We put the radios on separately than the suit. And then the radios that, they're not, I was talking about the voice radios. Like we have a headset and an actual, what's it called? A ham radio. It's a GMRS, I think, radio. Because we have our own frequencies out there that we actually have exclusive rights to, so there's no interference. So that's separate from the backpack and the helmet. But then the LoRa radio, the new thing, the mesh-tastic thing that has the coordinates going out, has the mesh data transmission capability, that also is separate. But we are talking about how to integrate all these things together. And then how would you also have AR You know, like imagine these glasses from Meta that they have out there, and stuff you've seen in movies where like you put on glasses and there's like a computer display. Like putting that on the helmet, where maybe you're not seeing this stuff on the helmet, maybe you're just seeing it out in the environment. But like that's something we want to work on and have soon. And as many of these things we could put into the suit as possible, we will. But it's, you know, this stuff is like high level engineering work and done by volunteers. So I think it's about $2,000 cost per suit right now for what we build. So if you wanted a bunch of them, you know, we could probably give you a quote, you know. We wouldn't be able to develop them for free because they're, you know, we would need, you know, they're expensive to develop, but volunteer wise,
I know you're busy. Please send me an email with the code. I know you're very busy.
What I'll do is I can connect you with Scott because you should really talk to him about it.
Thank you.
Yeah, sure. But we are like, there are others in the community that work on spacesuits as well. Like the folks at Biosphere 2, Sam, they're partnering with Larry Kuznets and the company that he has, where they have a pressurized suit, and they demoed that at our conference last year. And Mason, one of the engineers up on the Flashline mission that just got back, is on that team. So that's another example of a analog suit that might be useful for you.
And if you want them to look beautiful, Marufa, I would recommend you go to some Hollywood people because they do some fantastic work on
For now, Mars
design.
Society, you know, Mars Society have enough resources.
And the simplest one, like my advice, Marufa, if you're trying to just build a really simple analog suit, all you really need is you need the flight suit, which is the coveralls you get like from an Air Force supply store, a helmet, and that could just be a motorcycle helmet, you know,